Welcome back. Let's try and implement the lookup function, or the search function. We want to check if an item or a node exists in our tree. Let's see how we would go about this. The first thing I would want to do is to check if there is such a thing as a root node, if it's empty. So I could have done this .root equals null to check if the root is empty, or I can use the exclamation mark in JavaScript. And we'll just say return false, because if the root doesn't exist, then it doesn't really matter. We're not going to find that node. Otherwise, we're going to say, once again, let current node equal to this .root, very similar to what we did above. Remember over here. And you'll notice some similarities with what we did when we did the insert. We still need to traverse through our tree. But instead, our while loop is going to stop whenever the current node no longer exists, or we no longer have a node to go through. Because once we've gone through our binary search tree and it's null, that means we didn't find what we're looking for. So in this case, I'm simply going to say if the value that we're looking for is less than the current node dot value. In that case, current node is going to equal current node dot left, because we now want to go left. If the value is less than the current node value, that means it's not the same. It's not the node we're looking for. So go left, because that's where I can find something that might be less than the current node. Otherwise, and we'll use an else if statement here, which says another condition. So if that doesn't match, if the value is greater than the current node dot value, what do you think we do here? Well, we go to the right. So we're going to say current node is now going to be current node dot right. So we can keep checking to the right of us. And then finally, else if, that is another condition, and we can say if current node is dot value equals the actual value that we're looking for, that means we got a match. That means that node exists, so we're just going to return the current node. Nice and simple. And then finally, because we're not returning anything, we're just looping through the while loop until we find the current node, where we return the current node, or current node becomes null because we cannot find anything. If we don't find anything, just return false. The only way we return something other than false is when we find our node with the matching value. So let's see this. If I now run tree.lookup9, and I'm going to comment this out because we don't need to check that our tree is being made. If I click run, there you go. I get the 9 node that has reference to all the other nodes beneath it. If I look up 90, I'll get false because it doesn't exist. What about 20, which exists? Yep, we found 20. What about 170? Yeah, we found 170. It's a node, but has no left and right references because it's a leaf node. And then finally, 171 is false because it doesn't exist. Well done getting this far. Hope you're able to implement your own binary search tree. Once you get the hang of it, it's really not that bad. At the end of the day, each line should make sense, and traversing a tree should make sense to you by now. We also understand why we have big O of log n. Although we have loops here, like while loops, we're not actually iterating through every single node. We're only iterating using divide and conquer, something that you'll hear a lot of. Divide and conquer simply means we're dividing up so that we don't visit all the nodes. Each node that we visit, we make a decision to go left or right. I'll see you in the next one. Bye-bye.